In 2005, an astronomical discovery shook the foundations of everything we thought we knew about our solar system. It was a discovery that would forever change the status of one of humanity's most beloved celestial bodies, Pluto. The culprit behind this cosmic shakeup, a distant and mysterious object we now know as Eris. Picture this: astronomers peering through their telescopes on a cold January night at the Palomar Observatory, not knowing they were about to make a finding that would rewrite our astronomy textbooks. What they spotted in the dark depths of space would spark heated debates in lecture halls, observatories, and classrooms across the globe. You see, for decades, we had been comfortable with our 9 planets, teaching our children about them, making models, and memorizing their order from the sun. Pluto, despite being the smallest and most distant, held a special place in our hearts. But science has a way of challenging our most cherished beliefs, and this tiny world called Eris was about to do just that. Today, we're going to unravel the fascinating story of how this dwarf planet revolutionized our definition of what makes a planet, and forced us to rethink everything we thought we knew about our cosmic neighborhood. It's a tale of discovery, debate, and the ever-evolving nature of scientific knowledge. Before we dive deeper into this astronomical adventure, make sure to hit that like button and subscribe to Exploring the Universe to stay updated with more captivating stories from the fascinating world of astronomy. Let me take you back to a chilly January night in 2005. At the Palomar Observatory in California, astronomer Mike Brown and his team were doing what they loved most, searching the distant corners of our solar system. Little did they know they were about to make a discovery that would change astronomy forever. Using the observatory's powerful telescope, they spotted something unusual moving against the backdrop of stars, far beyond Neptune's orbit. At first, it was just a tiny dot of light, but this dot would soon become one of the most talked-about objects in our solar system. The team had a bit of fun with their discovery at first, giving it the unofficial nickname Xena, after the warrior princess from the popular TV show. It was meant to be temporary, but the name stuck around for months. What made this discovery particularly exciting was when they realized this mysterious object was actually bigger than Pluto. But here's where the story gets interesting. The team kept their discovery under wraps for months. Why? Well, they needed to be absolutely certain about their findings. Imagine having to keep such an enormous secret. They spent countless nights observing, measuring, and double-checking their data. The anticipation must have been incredible. When the official announcement finally came, it sent shockwaves through the astronomical community. Picture hundreds of astronomers around the world scrambling to their computers and telescopes, all wanting to get a glimpse of this mysterious new world. The discovery made headlines across the globe, not just because of its size, but because it raised a fundamental question. If this new object was bigger than Pluto, shouldn't it also be called a planet? The finding was so significant that it sparked what some astronomers now jokingly call the Great Planet Debate. It was this discovery that would eventually lead to one of the most controversial decisions in modern astronomy. But that's a story we'll get to in just a moment. Now let's dive into some truly fascinating features of this mysterious dwarf planet that shook our understanding of the solar system. Eris might be slightly smaller than Pluto in diameter, but don't let that fool you. It's actually 27% more massive. Imagine having 2 snowballs, and while one looks a bit bigger, the other is significantly heavier. That's Eris for you, packing more matter into a slightly smaller package. The way Eris travels through space is nothing short of dramatic. Its orbit is extremely eccentric, meaning it follows an elongated, oval-shaped path around the Sun. And talk about taking its time. Eris needs 557 Earth years to complete just one orbit around our star. To put this in perspective, when Eris last reached its current position in its orbit, Leonardo da Vinci hadn't even started painting the Mona Lisa. The surface of Eris tells us another fascinating story. Much like its cousin Pluto, Eris is covered in frozen methane, creating a crystalline blanket across its surface. This frozen world is unimaginably cold, with an average temperature of -230 degrees Celsius. At such extreme temperatures, gases we know as light and volatile on Earth become solid ice, but Eris isn't alone in its journey through the outer reaches of our solar system. It has a companion, a small moon named Dysnomia. This name choice is quite clever, actually. In Greek mythology, Dysnomia was the daughter of Eris, the goddess of discord and strife. It's like a small family drama playing out in the cosmos. What makes these characteristics even more remarkable is that we can observe and measure them from billions of miles away. It's a testament to human ingenuity and our relentless pursuit of understanding the mysteries that lurk in the darkest corners of our cosmic neighborhood. The discovery of Eris sparked what might be one of the most fascinating revolutions in modern astronomy. Imagine the scientific community suddenly facing a dilemma that would shake the very foundations of how we view our solar system. It was like finding a new piece of a puzzle that suddenly made you question whether you were doing the puzzle right all along. Here's what made astronomers scratch their heads. They had just found an object that appeared to be larger than Pluto, which had been proudly holding its position as our 9th planet since its discovery in 1930. The immediate question that arose was both simple and complex at the same time. Should Eris become our solar system's 10th planet? But this question opened a Pandora's box of deeper considerations. If we make Eris a planet, what about all the other similar objects we might find in the future? The Kuiper Belt, where both Pluto and Eris reside, could potentially hide dozens of similar-sized objects. Would we end up with 15, 20, or even 30 planets? This forced astronomers to confront an uncomfortable truth. In all our years of studying the cosmos, we had never actually defined what a planet is. Can you believe that? We had been teaching about planets in schools for centuries, but we never had a formal scientific definition of what makes a planet a planet. It was like realizing you've been playing a game for years without actually knowing all the rules. The astronomical community found itself at a crossroads: either accept Eris as a planet and potentially open the floodgates to many more planetary additions, or take a step back and create a more rigorous definition of what we call a planet. This situation reminds me of how science often works in the real world. Sometimes, a single discovery can force us to question everything we thought we knew. It's not always about finding answers. Sometimes, it's about realizing we've been asking the wrong questions all along. This debate wasn't just happening in scientific circles. It captured the public's imagination and sparked discussions around the world. After all, who hadn't learned about the 9 planets in school? The possibility of adding a 10th planet, or perhaps losing one we already had, touched something deep in our collective understanding of our cosmic neighborhood. Think about it. How many times in history do we get to witness science literally rewriting the textbooks? This wasn't just about Eris or Pluto. It was about our whole understanding of what makes a planet, and ultimately about how we classify and make sense of the universe around us. Picture this: a warm August in 2006 in the historic city of Prague. 424 astronomers from around the world gathered for what would become one of the most dramatic meetings in astronomical history. The beautiful Baroque architecture of Prague provided a fitting backdrop for a decision that would reshape our understanding of the solar system. This wasn't just another scientific conference. The tension in the air was palpable as these brilliant minds came together to tackle a question that, surprisingly, had never been formally answered since humans first started gazing at the stars. What exactly is a planet? You might think it's funny that we had been studying planets for centuries without having a proper definition, right? It's like playing a sport for years without official rules. But now, for the first time in human history, The International Astronomical Union was about to change that. After heated debates and discussions that would make political summits look tame, they finally established 3 key criteria that a celestial body must meet to be called a planet. Let me break these down for you in a way that makes sense. First, it must orbit the Sun. Simple enough, right? This immediately ruled out all those fascinating moons orbiting other planets, no matter how large or interesting they might be. Sorry, Titan and Europa. Second, it needs to have enough mass to achieve hydrostatic equilibrium. In everyday language, this means it needs to be big enough for its own gravity to pull it into a spherical shape. Think of it like this. If you throw a small rock into space, it stays whatever shape it is, but if you have something massive enough, gravity will naturally pull it into a ball shape. The third criterion was the real game changer. And honestly, the most controversial one. A planet must have cleared its orbital neighborhood. Imagine you're sweeping your path as you orbit around the Sun. If you're big enough to either absorb, push away, or control any other objects in your orbit through your gravitational influence, congratulations, you've cleared your neighborhood. This last requirement was particularly strict. Even Earth, with all its cosmic debris and asteroids, barely passes this test. But it was this criterion that would ultimately seal the fate of both Pluto and Eris. Neither of them had managed to become the dominant gravitational force in their orbits, sharing their space with numerous other objects in the Kuiper Belt. The vote that followed was historic, though somewhat controversial. Many astronomers couldn't attend the meeting in Prague, and some argued that such an important decision should have included more of the global astronomical community. But when the dust settled, these 3 criteria became the official definition that we use today. This meeting in Prague wasn't just about defining planets. It was about how science evolves, how we classify and understand our universe, and how sometimes the most basic questions can lead to the most profound changes in our understanding. The story of Pluto's reclassification is perhaps one of the most dramatic plots in modern astronomy. Imagine being a well-respected member of an exclusive club for 76 years, only to suddenly have your membership card revoked. That's essentially what happened to our beloved Pluto. When the new planetary criteria were established, Pluto easily passed the first 2 tests. It orbits the Sun, and yes, it's massive enough to be pulled into a spherical shape by its own gravity. But then came that third criterion, clearing its orbital neighborhood, and this is where our icy friend ran into trouble. You see, Pluto's relationship with space is a bit messy. Not only does its orbit intersect with Neptune's path, but it's also surrounded by thousands of other objects in the Kuiper Belt. It's like living in a cosmic apartment complex rather than having its own private estate. In fact, Pluto's orbit is so crowded that it's influenced more by Neptune's gravity than it influences its own neighboring objects. This situation led to the birth of a new category in our solar system family, the dwarf planet. It's important to note that being called a dwarf planet isn't a demotion in the way many people think. It's more like being recognized as a different but equally fascinating type of celestial object. Think of it as moving from being a small fish in a big pond to being a big fish in a new pond. Pluto and Eris became the founding members of this new celestial club, soon to be joined by other interesting objects like Ceres, Haumea, and Makemake. It's fascinating to think that this reclassification actually gave us a better understanding of our solar system's diversity. Instead of being the smallest and oddest of the planets, Pluto became one of the largest and most interesting members of a whole new class of objects. The creation of the dwarf planet category also helped us better appreciate the complex architecture of our solar system. It's not just about planets anymore. We now recognize that our cosmic neighborhood is filled with different types of objects, each with its own unique characteristics and stories to tell. Some astronomers compare this reclassification to the way we revised our understanding of dinosaurs and birds. Just as we now know that many dinosaurs had feathers and were more closely related to modern birds than we initially thought, our understanding of celestial objects continues to evolve as we learn more about them. This whole episode reminds us that science isn't about unchangeable facts set in stone. It's a constant journey of discovery, where new findings can reshape our understanding of even the most basic things we thought we knew. Pluto didn't change. Our understanding of what it means to be a planet did. Let me share some fascinating tidbits about Eris that will surely blow your mind. First, let's talk about that name. It's absolutely perfect when you know the story behind it. Eris was named after the Greek goddess of discord and strife, and believe me, this celestial body certainly lived up to its namesake by stirring up quite a controversy in the astronomical community. The naming doesn't stop there. It gets even better. Eris's moon was cleverly named Dysnomia after the daughter of the goddess Eris, who was the deity of lawlessness. It's like a little family drama playing out in the cosmos. The astronomers who chose these names definitely had a sense of humor, considering all the chaos this discovery would cause in the scientific world. Now, let's talk about just how far away this troublemaker is. Currently, Eris is sitting at a mind-boggling distance from the Sun, 3 times farther away than Pluto. Imagine being so far out in the solar system that our Sun appears as just a very bright star. At that distance, the amount of sunlight reaching Eris is so minimal that you'd barely be able to read a book in the middle of its day. But here's something that might surprise you. Despite being so incredibly far away, Eris is actually bright enough to be seen through powerful amateur telescopes. This isn't because it gives off its own light, but because its surface is incredibly reflective, almost like a cosmic mirror ball. This high reflectivity comes from its surface of frozen methane, which creates a sort of crystalline sheen. Perhaps one of the most exciting aspects of Eris's discovery is how it opened our eyes to a whole new population of objects in our solar system. It was like finding the first piece of a puzzle you didn't even know existed. After Eris was spotted, astronomers began finding dozens of similar objects in the outer solar system. It's as if Eris was the key that unlocked a treasure chest of new discoveries. This cascade of discoveries completely changed our understanding of the solar system's architecture. We went from thinking of our cosmic neighborhood as a neat, orderly system of 9 planets to realizing it's more like a cosmic metropolis with different neighborhoods filled with various types of objects, each with its own fascinating story to tell. Think about it. Just a few decades ago, we thought we had our solar system all figured out. Then along comes Eris, proving that even in our own cosmic backyard, there are still amazing discoveries waiting to be made. It really makes you wonder what other secrets are still hiding out there in the darkness of space, just waiting for us to find them. When it comes to Eris and the Great Planet debate, the astronomical community has some fascinating perspectives to share. Let's start with Mike Brown, the astronomer who discovered Eris. He famously compared finding Eris to discovering a new continent, and there's real weight to that comparison. Just as finding the Americas changed Europeans' entire worldview, discovering Eris transformed our understanding of the solar system. Brown, who playfully calls himself the man who killed Pluto, actually takes pride in helping us better understand our cosmic neighborhood, even if it meant challenging our long-held beliefs. Then there's Neil deGrasse Tyson, one of astronomy's most charismatic voices. Long before the official decision to reclassify Pluto, Tyson had already made waves by arranging the American Museum of Natural History's planetary display in a way that questioned Pluto's planetary status. He became one of the most vocal supporters of the new classification system, often explaining to the public why this change made scientific sense. As he once pointed out, if you drove through the asteroid belt, you'd need to add dozens of planets to our solar system if we kept the old definition. But here's where it gets really interesting. The debate about what makes a planet is far from over. Some astronomers argue that our current definition is too restrictive. They point out that even Earth, technically speaking, hasn't completely cleared its orbital neighborhood. We still have plenty of asteroids and space debris sharing our orbital space. Alternative classification systems have been proposed that would dramatically change how we categorize objects in our solar system. One fascinating proposal suggests we should classify planets based on their geological activity rather than their orbital characteristics. Under this system, some moons like Europa and Titan might actually qualify as planets because they're more geologically active than Mercury. Another intriguing perspective comes from planetary scientists who argue that we should focus more on an object's physical properties rather than its location or orbital dynamics. They suggest that if an object is big enough to become round under its own gravity and has interesting geological features, it should be considered a planet, regardless of where it orbits. The debate has even sparked philosophical discussions about how we humans categorize things in space. After all, nature doesn't care about our labels. These are tools we create to help us understand the universe better. As one astronomer beautifully put it, the universe is a spectrum of wonderful objects, and trying to put them in rigid categories is like trying to decide exactly where red becomes orange in a rainbow. What's particularly exciting about these ongoing debates is how they reflect the dynamic nature of science. Unlike what many people think, science isn't about unchangeable facts written in stone. It's a living, breathing process of discovery and discussion, where new evidence can always lead us to adjust our understanding. Some astronomers now joke that there are as many planet definitions as there are planetary scientists. But rather than seeing this as a problem, it's actually a sign of how much we're learning about our solar system. Each new discovery, each debate, and each proposed classification system adds another layer to our understanding of the cosmic dance we're all part of. When we look up at the night sky, what we see often feels permanent and unchangeable. For generations, school children learned about our 9 planets, reciting their names in order from Mercury to Pluto. But the discovery of Eris shattered this comfortable certainty, reminding us that our understanding of the cosmos is always evolving. The reclassification of Pluto wasn't just a scientific decision, it was a cultural earthquake. People around the world responded with surprising emotion. Save Pluto campaigns emerged. T-shirts were printed and petitions circulated. Some US states even passed symbolic resolutions declaring Pluto would always be considered a planet within their borders. This passionate response revealed something profound. We form deep attachments to our scientific knowledge, almost as if these distant objects are part of our extended family. Why did so many people care so deeply about a small frozen world billions of miles away? Perhaps because Pluto had become more than just a planet. It was a symbol of our childhood education, of what we thought we knew about our cosmic neighborhood. When its status changed, it forced us to confront an uncomfortable truth. Our knowledge is never truly complete or final. This is the beautiful lesson that Eris teaches us. Science isn't a collection of unchangeable facts, but rather a method, a journey of discovery that constantly refines and sometimes completely reimagines our understanding of reality. The most important scientific mindset isn't memorizing today's facts, but remaining open to tomorrow's discoveries. The Eris saga demonstrates perfectly how scientific progress actually works. Rather than seeing the reclassification as a failure, we should recognize it as science at its finest, willing to revise even long-held beliefs when new evidence emerges. This flexibility is science's greatest strength, not its weakness. Today, astronomers continue mapping our solar system's outer regions, discovering fascinating objects that blur the lines between categories we once thought were clear-cut. Each discovery adds new pieces to our cosmic puzzle, revealing a solar system far more complex and fascinating than we ever imagined. So when we look at Pluto and Eris now, we shouldn't see demotion or controversy. Instead, we We should see an invitation to wonder, to question, and to embrace the beautiful uncertainty that drives us to explore further. After all, the most exciting scientific discoveries aren't the answers we find. They're the new questions that emerge along the way. As we reach the end of our journey with Eris, we're reminded of something truly remarkable about science. It never stands still. The story of this distant world shows us that even our most fundamental categories and definitions are subject to change when new evidence emerges. Think about it. For 76 years, Pluto stood unchallenged as our ninth planet. Generations grew up with this truth firmly established in textbooks and planetarium shows. Then in the span of just a few months, a single discovery forced astronomers worldwide to reconsider everything they thought they knew about what makes a planet a planet. This is the breathtaking beauty of astronomy and science as a whole. Unlike dogma or tradition, scientific understanding evolves, adapts, and sometimes completely transforms in the face of new discoveries. Eris didn't just change our solar system map, it changed how we think about our place in the cosmos. The ancient Greeks looked up at the wandering lights they called planets and built elaborate models to explain their movements. Copernicus dared to place the sun at the center of our system. Galileo turned his telescope skyward and saw moons orbiting Jupiter, each discovery built upon the last, sometimes confirming, sometimes revolutionizing what came before. And now we stand at another fascinating moment in this grand tradition. The debate about Pluto's status continues even today, with some planetary scientists advocating for yet another redefinition that would restore Pluto's planetary status while including Eris and several other worlds as well. Science marches forward, never fully settled, always open to new perspectives. So the next time you look up at the night sky, remember that what you're seeing isn't just stars and planets. It's an ongoing conversation between humanity and the universe. A dialogue that has continued for thousands of years and will continue long after we're gone. And isn't that what makes astronomy so utterly fascinating? Don't forget to subscribe to Exploring the Universe, hit the notification bell so you never miss an episode, leave a like, and share this video with your friends. Join our community of cosmic explorers as we continue to unravel the mysteries of our incredible universe, one discovery at a time. Until our next adventure among the stars.